Propagation of electromagnetic waves. The transmission of electromagnetic wave is hindered because of the phenomena of attenuation. Hence, we choose to transmit medium with proper bandwidth. The atmosphere also plays a vital role in transmission of electromagnetic waves. From this, there can be three types of electromagnetic waves: ground wave, sky wave, and space wave. Ground wave. At large wavelength, that is, at low frequencies, the antennas required for efficient transmission are large in size. This is because antennas should have the size comparable to wavelength, that is, at least approximately equals to lambda by 4. These antennas are mounted on the towers which are considerably near the ground. Thus, the ground has considerable influence on the waves being transmitted. In the figure, you can see the antenna showing various transmission of wavelengths. The ground wave propagation can be shown as follows. Since the wave propagate near the surface, they are known as gliding waves or ground waves. Also, among other means of propagation, are most attenuated. Sky waves. In the frequency range of 30 MHz to 40 MHz, long distance communication can be achieved by reflection of waves from ionosphere. Since the degree of ionization varies with the height, the ionosphere reflects certain range of frequencies. Space wave. A space wave travels in a straight line from the transmitting antenna to the receiving antenna. They are used for line of sight communication as well as space communication. In case of space wave, we have a formula dt equals to root of 2r ht, where dt is the distance of the horizon from the transmitting antenna, r is the radius of the earth, ht is the height of the transmitting antenna. Also we have formula dm equals to under root of 2r ht plus under root of 2r hr, where dm is the distance between the two antennas, ht is the height of the transmitting antenna, and hr is the height of the receiving antenna. Suppose we want to transmit an electronic signal whose frequency is less than 20 kHz. Let us analyze what factors affect the transmission. First, size of the antenna or aerial. Second, effective power radiated by the antenna. Third, mixing up of signals from different transmitters. Let us take them one by one. Size of the antenna or aerial. The antenna should have size comparable to that of the wavelength of the signal. At least the antenna size should be lambda by 4, where lambda is the wavelength of the signal. Power radiated by the antenna is directly proportional to 1 by lambda square. Since the bigger antenna has more length, the power radiated by that bigger antenna radiates more power.